Now we talked about absolute convergence. Just to remind you of the big ideas, alternating negative is often done this way, or sometimes this way if they're feeling kind of daffy. Cosine of full pies are positive and negative ones, depending on if it's 1 pi, 2 pi, and so on. Yeah? Alternating negative helps convergence because it keeps it from going out of control positively or negatively. It's a back and forth kind of thing. And last but not least, if the series doesn't need the alternating negative to converge, then what do we call that? Absolute. It converges absolutely with absolute value, removing the sign. All right. Now the question of the day is, all right, so maybe it didn't converge absolutely. How could you prove that it does converge? I did have an extra copy. I said, do we have any extra copies? They're killing me. Sorry, I digress. So how do you prove conditional convergence? And it's really a really low bar to meet. It's really pretty easy to converge conditionally because the alternating negative does so much. An infinite series converges conditionally if it doesn't converge absolutely, but the series does converge by virtue of the alternating negative. Okay, so you can't converge absolutely and conditionally. It's if you don't need the negative, it's absolute. If you do need the negative, then it's conditional. And if it's even with the negative, it still diverges, then that's divergent. So there are 3 cases, all distinct. There's no overlap. Absolute convergence, conditional convergence, divergent. You with me? There's nothing else. All right. Now, to prove something converges conditionally, this is sometimes called the Leibniz test. You just need to meet 3 standards. First of all, it has to be alternating. That makes sense. Conditional convergence is only an alternating deal. It's not a all positive term. That doesn't apply to all positives. Okay. Second is the terms have to go to 0. That's still always going to need to be met. That's a divergence theorem. Otherwise, it has no chance. If they don't go to 0, then it's just going to spiral out, not in. And then last but not least, the terms have to steadily decrease in absolute value after some point where the terms are getting less and less. Now, it feels like these overlap a lot, and there is a lot of overlap, but I'll show you what I mean in as far as what the work should look like. But if terms do these things, they alternate, then they'll go back and forth. If the terms go to 0, then every time I knew this, by the way, this represents the sums as you add more terms. Okay? Now, if the terms go to 0, then every time it alternates signs, then the total will either go positive to negative or vice versa. It's going to go do a lot of this back and forth kind of deal. And if the terms get smaller and smaller, then the amount of jump between terms will get smaller and smaller and gradually decay towards some kind of limit. Now remember, the terms have to go to 0. The sum doesn't necessarily go to 0. The sum could approach a half or something. All right, so this is what you'll typically do. Something like this. If the question asks, does this series converge absolutely, conditionally, or diverge? First thing I want you to do, always, is check divergence theorem. Do the terms go to 0?
Yes.
They do. The alternating negative is fine, but the denominator gets bigger and bigger, and dividing by bigger and bigger approaches 0. You follow? Okay. Now, let's see if we don't even need your help, right? If I can just do this without the alternating negative. So if I check absolute convergence, then I would say something like the positive term series is 1 over n to the half, which diverges. And why do we say that? P series with P equal half less than 1, yeah? So from that, what do we conclude about absolute convergence of the alternating series? The alternating series does not converge absolutely. Okay, that's the first part of my answer. It said, investigate if it converges absolutely, conditionally, or diverge. Well, the first thing I look at is, does it even have a chance? Because that's the quickest way to answer a question. But then I look at absolutely. Now maybe it will converge by virtue of the alternating negative. This hasn't, did I cut this off?
Yeah, it's cut off.
Is it N or N plus nothing? Okay, it doesn't matter. Okay, cool. Now, this is the new stuff of the day. All right, so say it was a question where it didn't converge absolutely. Maybe it converges conditionally. So the first thing you're gonna basically do a bullet point or check off each condition. The series is alternating. And why does it alternate?
Because the negative one.
Because of the negative one to the end, it alternates between negative and positive terms. Yeah. All right. Cool. What about the terms? I know I've already said it in my work, but do the terms go to zero? They do. And then last but not least, the only thing that requires a wee bit of work is proving the terms decay as you go down the list. The next term, you prove generally that the next term is less than the previous term, so that what you're adding is getting smaller and smaller. That needs to be met. Now, let's start with, for the third condition, I think we can all agree that n plus 1 is greater than n. Yay? Would you also agree that 1 over n plus 1 is less than 1 over n? And that then means that the terms, now when I say the terms, I mean without the sign. I know the alternating sign thing is going on, but in terms of the number of the terms, the value of the terms, that implies that the n plus 1 term's value is less than the one before its value. The terms are getting smaller is what that means. Yes? That's just, I'm trying to prove the third condition that the terms get smaller, and you just typically start with the fact that n plus 1 is greater than n, and we're trying to establish this. This is not my main goal. That's just a truth that gets me started. This is what I want to get to, is that the terms get smaller for this problem. Oh. Okay? So this is pretty much your starting point, always. Yes?
Do we not need to include the whole n, the 1/2?
You do not, oh, you do. What the freak? Sorry. Yeah, I'm sorry, I'm dumb. Thank you. Yeah, the half kind of... would you agree that if I extended this, then that means n plus 1 to the half power is also less than 1 over n to the half? Question for you. Could I have done that in a different order? Could I have done the half first and then reciprocals, and would that have worked also?
Yep.
Yeah, it would be fine too. So the order doesn't necessarily matter there. But that does imply that the n plus 1 term is less than the nth term, and therefore, because all those 1, 2, 3 conditions of the theorem are met, a series is conditionally convergent. If those 3 things are met, then we conclude the series converges conditionally. It's alternating, which helps convergence. The terms are getting smaller, so it has a chance, and therefore converges conditionally. You with me? If I took a calculator to this and I did 20 partial sums and 100 partial sums and 1,000, you would see it approaching a limit. It does not go out of control. Okay, would you try this one, please, on your own?
minus j equals 2.
So much writing. Some quality stuff tends to creep me out. Excuse me. How's it going? Okay. Did you check for divergence theorem? Do the terms go to zero and it has a chance?
Yes.
Did you remove the negative to look at absolute convergence? Which unfortunately is not just a layout that could have been taken harmonic, but oh well. So real quick, this is good test practice at least. By comparison tests, limit comparison test 1 over n, I got that the positive terms diverges because it's like harmonic, yeah?
Yes.
And therefore the alternating does not converge absolutely. So on to conditional I go. I state that the series is alternating, that's the first condition. The terms go to zero. It feels like that's a waste of my time because I already had that in my work. But
Can we not just like check off from there to the top?
yeah, I don't know. My
Or
professor was
we
a
don't
total.
write anything at all at the top and we just write it there?
I hear you. The problem is, if the terms didn't go to zero and you didn't catch it, then all that's wasted. But if you looked but didn't write it till later, that would be smart. Are you talking to me or was him?
I was talking.
Oh, okay. Can you tell your voices? Can anybody tell their voices apart? You can?
Yeah.
Turn around. All right.
I can tell my voice.
Who just said that? Wow. Really? Wow. That's pretty amazing. All right. Now then, we conclude what? That the series converges conditionally. All right, so now, that's the worst case. Those are the worst. Do you feel like you got this and you're ready to go? All right, I don't think that you can do this one quite frankly. So do that one first. Do those two. Do those two first. That third one you definitely want to get in your notes. It's a classic trick case. All right.
I was absent.
No, it's okay. My bad. I'm sorry.
How you doing on this third one?
It's amazing.
I'm so
Absolutely. At one point, yes.
It's not alternating.
Well, but either way, the terms are still either
Wait, how is it not
multiplying the terms
alternating?
by
Because it's not
less
something
than
like
one. So either way, it just makes the terms smaller.
Either way, it makes the terms smaller.
It gets bigger still.
So you're using what? Conditional?
Later time.
What? What do you mean?
What are you proving? Conditional or absolute?
Yes.
Okay, absolute. So do the terms go to zero first of all.
Yeah.
Okay. So this. Now that is still the absolute value of cosine of n over 3 to the n, yeah? It's not cosine of pi n, it's cosine of n. And does this converge?
Wait, why does it matter when they're not multiplied by a number?
Because cosine of 1 radian is not the same as cosine of 1 pi. And cosine of 2 radians is not. So if you did the cosine of 1 radian's about here. Is cosine positive or negative there? Positive. Cosine 2 radians is about here. Is cosine positive or negative there?
Negative.
Negative. Cosine 3 radians is about here. Is cosine positive or negative there?
Wait a second.
It
That's
is
not
alternating.
right.
Yeah.
Wait a
Besides
second.
just
Positive, negative,
negative.
negative. Not alternating. Okay. 1 radian, 2 radians, 3 radians. Not 1 pi, 2 pi, 3 pi. That's different. Okay. Cosine of 1 radian, 2 radian, 3 radians. That doesn't alternate. And that's not a nice 180 degrees each time going clean. It's going about 57 degrees each time. That's going to be all over the place sometimes.
That's me yucky.
Sometimes positive, negative, negative, positive, negative, positive. It's not alternating. Not alternating. So, your only hope is it's not conditional because it's not alternating. So your only hope is absolute. Oh, with absolute and some outside the box direct comparison testing. So, tell me, what do you know about cosine?
It's always less than 1.
Cosine of n is always less than or equal to 1, yeah? All right, where do you go from there?
Wait a
Why is
minute.
that?
cosine of n over 3 to the n must be always less than or equal to 1 over 3 to the n. Now, I don't need that in absolute value because it's positive anyway, but you can put it in absolute value if you like. You doubt? And therefore, the sum of all those expressions must be less than the sum of all these expressions. And that is convergent. Finite. Okay? And so we would conclude that the positive term series converges because it is less than 1 over 3 to the n, which converges. Why do you say that? Geometric with r equal 1/3 less than 1. Therefore, the alternating, or that series, it's not alternating series, the series, I guess I'll call it, the series converges absolutely. If I remove the sign, it still converges, and therefore it converges absolutely. Follow? That was a harder one. Okay, what about the fourth one? That should be a layup.
It goes to infinity.
Yeah, the terms don't go to 0. It has no change. That's always why you check the first thing. The terms go to, do the terms go to infinity?
Yes.
Yep.
Where do they go to?
Negative.
Yeah, they go to positive and negative infinity. They do this. So I would say something like, I guess you could say that, or you could say oscillates, but you can definitely say does not exist, and therefore the series must diverge. You can't add terms that are just all over the place. All right, a couple other fine points. This bad boy, say you put this in summation notation. Would you express that in summation notation, please?
3 plus 1 over.
Is this supposed to be, this I think is supposed to be, oh no.
It's
Ooh. And it's not a mistake. Okay, I remember that. Okay. So, what do you think there, people?
3 plus.
Very interesting. It is.
So
It's
we
not
not just
convert.
take 3 plus, or is that wrong?
3 plus. So yeah, if this is not part of the pattern, then write when the pattern starts. Okay?
Oh.
And then deal with the converging series part of it. That's not really part of the pattern itself. What would you call the, you want to start n at 1 or 3?
3.
All right, start at 3. That makes the denominator easy, but you do have to deal with the alternating negative. Negative 1 to the what? N or n plus 1? Does n work?
N plus 1.
N does not make a positive term, so it needs to be n plus 1. Yay?
So the denominator still has to be.
And then it's not 3, I'm dumb. Sorry, what is the denominator?
N.
N. Okay, yay?
Oh.
All right. Now, if we were asked about convergence of this, what if the question said just, does this converge? Now, that reads differently than this question here. When the question says, does the series converge absolutely, conditionally, or diverge, then you got to do it all. You got to prove it does or doesn't absolute, it does or doesn't conditionally, or diverges. But if it just says, does it converge, then I can kind of look at this and say, well, absolute, what do you think?
No.
It's not going to go absolutely. It's like harmonic, yeah? So I'm not going to even go there because it didn't ask me to get into absolute. It just does it converge. So what about, let's just go with conditional. Does the series alternate? Yes. It does. Do the terms go to 0? And do the terms decrease in value? if I were to take the reciprocal, is it 1 over n plus 1 less than 1 over n? And therefore, the absolute value of any term, the n plus 1 term is less than the absolute value or the number associated with any term before it. And so we would say this series converges. And if you wanted to parenthetically say conditionally more better, but conditional convergence is convergence. Follow? All right. Then the last one. 1 plus a half minus a half. Minus 1 over 2 squared. Plus a third minus plus 1 over 2 cubed. What did you do?
Scream.
I have two different ones, because there's two different things.
Okay, yeah. If you don't see one pattern, if you feel like, oh, that I definitely see,
Yes, I see that.
to the first, to the second, to the third, and that's something else, well then you have every freedom to write this as two series. This is the series for the green, and give me the rule for the green. Okay, let's do the easy part first. The denominator is just n, and we're going to start n, that means at 1. And do we have an alternating negative there? We do. Negative 1 to the n, or n plus 1? N plus 1. Right here. Okay, that covers the green, right? Right, now let's cover the yellow. What would you say about the easy, just focus on the easiest part of the pattern first. What's easy to see the pattern in? The denominator is 2 to the n. The minute you put down a part of a rule, that forces your starting value. In this case, n must start at 1. Now the alternating negative. Negative 1 to the, your choices are n or n plus 1. Whichever one works. N plus 1? Okay. And then converge or diverge. Let's just kind of outline this. Converge or diverge? Converge conditionally. We could prove that converges conditionally. What about this one? Converges absolutely. If I remove the negative, it would still be geometric, or I could just look at it as geometric. But if they both converge, then the total problem must converge. The total converges. Okay? All right. Now, obviously, that's just a rough sketch of the big ideas, but I assume you're good. I think I'll let this. Actually, let's just do part A. Okay? Would you give me the set of all x values? This is called a power series. Would you give me the set of all x values that would make this converge in any way, conditionally or absolutely? I just started trying stuff myself. What are you thinking?
That one doesn't.
Does 2 converge?
Yes.
If if I asked what is 0 plus 0 plus 0 forever, could you tell me what it has?
Yes.
Converge.
Yes.
Yeah, really converges. Okay. What about x equal 3? No, that's harmonic, yeah?
Yeah.
So that's diverging. What about x equal 1?
Yes.
It's alternating harmonic. We know that that converges conditionally, yeah? What about anything in between? Can I take x's in between? I know n can only be whole numbers, but x can be real numbers. So what about 2.5? What would that look like? 0.5 to the n over n.
Not good.
Would this help it converge?
Maybe if you want.
This isn't this geometric?
Yeah.
Which wins, geometric or that?
Geometric.
That I could be by ratio test, but that's definitely going to converge. That will converge, okay? Because you're getting pieces. So the set of all x's that would converge seems like 3 is the point where we start to fail, but less than 3, like at x equal 2.99, 2.99 minus 2 is 0.99 to the n over n. Will that converge? Yes, the exponential will win. It'll make it get smaller. So it seems like right up to, but not including 3 is good to go. What about on the negative side? Can I just go forever negative? Or what if I tried x equal 0? Would this converge? Negative 2 to the n over n? No, that's a base. Those terms don't even go to 0. You follow? So it ends at 1, and do we include 1? Yeah. That's called the interval of convergence, which we'll talk about later. Yeah, but that's a good start. All right. Do you have 137 still, or just 137B? 137A? Okay, here we go.
It's really yucky, really fast.
137. Tomorrow's an ends day, so we won't have a lesson tomorrow, so maybe we can get for this. All right, so 137. What questions do we solve in 137? 8, 5, 8, and 5.
Actually, double check, make sure that was right.
Oh, okay. So you just had it out of random number.
No, I got it right. I was remembering from this morning, but I didn't have time to actually spell it.
All right. 8. 8. So this is No Me Gusta. Okay. Would you change, this will actually be a good practice of what we just did. Would you change it to this is what I meant to do? We don't have the wherewithal to do sine of n over n. So let's go sine of n over n squared, right? Now, using the ideas we just talked about, can you prove this converges absolutely? Now, I know generally we think of absolute convergence as an alternating thing, but it really just means if we remove sine from the calculation, does it converge? So if we remove sine from the calculation, and by sine I mean SIGN sine, not sine, guys, okay, if I remove the positive and negative component and just look at the absolute value, does it converge? Well, let's see how it went a second ago when I taught this. Can I prove this converges by direct comparison test? What do I start with? The fact that the absolute value of sine is
always less than 1.
less than or equal to 1. And then what? Sine of n over n squared is less than 1 over n squared. Again, absolute value. All right, cool. What about all the terms of those formulas then? Wouldn't the sum of all the terms of those formulas also be less than 1 over n squared? And does 1 over n squared converge or diverge? Converges. And so we have proved less than, positive term series less than converging, and therefore must converge. So we would say sine over n converges because it is less than 4 over n squared, sorry. Because it is less than squared, which converges. Why do we say it converges?
P series.
P series P equal 2 greater than 1. Now because the positive converges, then the series converges. Absolutely. Yeah? All right. Okie dokie. 5, so Kylie, you have 5? All right, so basically 5, anytime you integrate a piecewise, you have to show the pieces being integrated. So you should go from -4 to 2, -2, sorry, and then use the first branch where that is applicable. And integrate that. Then you should go from -2 to 1 and use the second branch. That's how you integrate these plus 1 to 4 on the last branch.
Okay, thank you.
You're welcome. All right, so 137 is done, and now we're on to 137B. How did the old Janet's driveway problem go? A was probably pretty straightforward. It went fine. Did you get A is 142-ish? Does it say it around? So should I round? No. 142.746 cubic feet. Wait. I got 746. Is that all right?
Yeah, I got
275?
Yeah.
So you have some, I'm sorry, say what you have again?
142.275.
Oh, I wonder what happened. 75. I would say I had it in my calculator wrong, but it's pretty close. I wonder if I knew. No, what I did. Okay, cool. The rate of change on the volume of snow at 8 a.m. Is there just one right here at work or two? We'll finish going over this tomorrow. 137A is due today, but have a lovely day.
Excuse me.
Thank you.
Oh no!
Oh no.
There's a little baby breath. It's okay.
So we gotta do 137B with the A with the B.
It'll be okay.
Fine, yoy.
That's how I feel. Still getting over the ache before. Guys, why is Cornell emailing me? Cornell is still emailing me. Like, if I was going to apply to Cornell, I would have done it. We're doing our. Are they still taking applications? They keep doing this thing where they just extend it to like, we'll open it up just for you. And it's like, please stop. If I was gonna do it, I would have done it. No, I changed emails because of it. I got so sick of getting emails. Yeah. Yeah. It was driving me insane. That's kind of interesting. It got to the point where I was getting 10 or 15 emails by day. I still get emailed daily from Purdue, but because I was admitted that I have to have my email address.
I used to check every single email but then the colleges started emailing me like this.
Yeah, I don't think it's anything right.
I know, I got it.
Nick Vereen to the main office. Nick Vereen.
could you recommend that fun sheet last night with the integration?
It was awesome.
That was a humdinger.
Humdinger.
Then the amount of snow she got seemed very not sensitive.
Really?
Yeah. 142 cubic feet of snow.
What's wrong with that? That seems
I
like.
lost it. Well, I can't tell if that's estimate.
Does that seem like a lot? 142 cubic feet? If a driveway is 20 feet wide by even, yeah, I mean, that seems like nothing.
It's actually
Yeah, that's not very deep snow. Hi.
Just so you guys, your kids know, the test goes through 107, so it does not include multiplying matrices.
Okay. That's
no, I
fine.
didn't get my
Except
accepted.
it's 107 with a supplemental also sigma.
Yeah, me and my
So it's a 107 plus sigma.
107 plus.
You see the test.
I did not get it.
I'll look at it after.
I was rather sure.
Thank you.
Republican, I switched unaffiliated like 3 weeks ago. So, I don't know.
Can you do both?
Maybe I can check my mail and.
Oh,
I have to go check my mail.
not yet. Gotta take it out to the old library today.
Good old library. Does Carmen
Is there a drop off at Carmody?
Is that where like the
Think
house
what?
is?